Good morning, ladies and gentlemen, dear colleagues.
Ladies and gentlemen, сегодня мы начинаем.
Today we are starting our second day of the conference. I was assigned to inaugurate day number 2. It's always the hardest, especially after the reception. Perhaps this is why we don't see so many people in this room. I would like to invite to the stage our colleagues who are going to have a panel discussion together with me. I invite here Woo-Hun Choi, Vice President of SI Imaging Services, Fabrice Rodriguez, Head of Reseller Growth of Airbus Defense and Space, and Ilya Yudin, Sales Manager of Maxar Technologies, United States. The title of our panel discussion today is Earth Remote Sensing Satellite Systems, and on this stage we have now, I believe, the chief representatives of the industry, Airbus from France, United States, Korea, and Russia, of course. That is why, without further ado, we're going to discuss national Earth remote sensing systems, how they function, what are their purposes and functions. We'll exchange experience, especially Russia is looking forward to the exchange on the best practices on how to commercially use the remote sensing systems, because one of the particularities of the Russian Earth remote sensing system is that it is state-owned and there is no private sector at all. So how do I go about this? Is there a remote or something? If I'm allowed, I won't even approach the rostrum at all. Can you upload my presentation on the screen, please? We'll be having a discussion with it in the background. It's no secret that all national aerospace systems have a lot of similarities, and the principal elements, there are 3 or 4 of them, and the principal element, of course, is the orbit constellation, the most important part of... Will we have the slides or not? Thank you very much. That is why, against the background of with the Russian constellation in the background, would like to have this discussion. Naturally, any national space system is represented by different types of spacecraft, and we have plans on how to further develop them. There are really existing constellations, and in Russia at the moment, as of now, as part of a constellation, we have 11 spacecraft. And just like in any other space system, they are subdivided into different types. We have 2 satellites which are hydrometeorological ones, which are Electron, Meteor, and Resource P and Canopus are natural resources apparatus. They're also used for mapping applications. And today I'd like to try to answer the question whether we need a specialized mapping aerospace system. As far as I understand, this is what we hear from the United States and in Europe. I know about Korea. Is there a specialized mapping or cartography constellation which is designed exclusively to do that? Russia doesn't have such a dedicated system. We had plans to launch it as about 5-7 years ago, but then we came to a realization that the highly detailed space imagery, such spacecraft as Resource P in Europe, there are Pleiades, they do it anyway. the full scope of that, but just applying special modes of imaging. It's almost always nadir image taking and acquisition and high georeferencing with high resolution and precision. Now in Russia, we decided against such a dedicated constellation, although for this imaging we did order 2 spacecraft of the series ICE. They will have mounted some of the cameras for exactly such kind of imaging. We plan to launch this spacecraft in 2023. They will be manufactured by RKC Samara. The resolution will be 2.5 to 3 meters, but most importantly, it will be stereo imaging. It is one of the particularities. Second important thing of our Russian system, or rather its deficiency, is that we don't have radar systems. This is a serious deficiency that we have. We have tried and are trying to rectify it, but unfortunately only next year we have plans to launch spacecraft Condor. This is the first of the series that will have 1 meter resolution, and radar will have a traditional conventional radar imaging. We have plans to manufacture a total of 3 such spacecraft to position them in such a way that we can do interferometry and get the relief of any landscape. Besides, we have plans to launch Obzor-R. This is planned for 2021. Again, another radar satellite. Now, we have all the reasons to be proud, and what this slide shows, this is back from a month and a half ago when we completed the Canopus V constellation. 6 satellites in the system are built in such a way that they can do all-out coverage of the area without any gaps, to do mosaics, to solve the tasks that Russian President instructed us to do, the Digital Earth project, not only for Russia, but for the whole world. And this system, in all its existence since 2012, after the launch of the first spacecraft, which is still online, working successfully in the system, we have acquired about 2 billion square kilometers of remote sensing data for the whole area of 2 billion square kilometers. I think it's quite a significant and commendable number. On a daily basis, they acquire 2 million square kilometers, and that is why in 1 month, this system, built like this slide shows, allows us to cover the whole territory in 1 month's time. Naturally, it doesn't take into consideration the weather conditions, cloudiness. That's why I keep saying that it's important for us to have radar images as well. So this is the integral capacities of our sensors mounted on this spacecraft. Everybody knows about them. In fact, the mounted equipment allows us to do everything we want, starting from the panchromatic 0.7 meter resolution. This is resource P, and do hyperspectral imaging in Canopus. We have infrared camera that allows us to do infrared acquisition and find out fires and other thermal events. Do the acquisition each 15 or 30 minutes from electro spacecraft for hydrometeorological purposes and a number of environmental projects. In fact, the whole range of hardware is there, with the exception of one thing. I told you previously, we don't have radar imaging hardware, but we're trying to solve it. I'm going to page through it and show you the images from all those spacecraft that we have, and a few words, I've already mentioned it, a few words about the development and improvement of our system. Space system, the aerospace segment of the Earth remote sensing system of Russia. The main document for us is the Federal Space Program, and here you can see some of the parameters from that Federal Space Program of Russia. To replace the resource P, we'll have resource PM with a resolution of 0.4 meters. Next year, we plan to launch the first Arctic series spacecraft, a specialized space system that will have oblong orbit, so that it would allow us to observe North Pole of Russia 15-30 minutes, just like Electro satellite, which is on geostationary orbit. Together with Belarusians, now we have completed building a design for the new project, Russian-Belarusian Earth remote sensing system. These are the satellites with a resolution 0.3 meters. The satellite will be developed by the company VNIA, and the actual payload will be designed by Peling, Belarusian company. They have huge experience, but that comes from a different program. So these are the parameters that we are eyeing here, and by the end of 2025, starting from 2022, we have plans to have on orbit about 20 spacecrafts, 20 satellites, each one of them designed for different spectral ranges, for different resolutions. At least we expect that such a constellation will help us solve all the problems that we have. But with one single caveat, that all this Russian constellation is state-owned. And at the moment, we do have a problem with the commercial use of the acquired data, especially from the Canopus constellation. We have huge volume of data, but this data can be used only for state purposes, and for commercial use, especially at the global market, they're almost unavailable. Although I believe, and according to the assessment of our Russian community of Earth remote sensing, this resource might be quite popular and could be of great use to be disseminated on the global market as well. And I would like to learn from you colleagues whether this thing can be privatized, or maybe colleagues can help us in distributing this data for us. Although our intent to do distribution within Russia didn't lead to any success stories. 8 or 10 distributors that we have in Russia who we signed the agreements with, but they're not doing a great job, perhaps. And in the past 2 years, we have sold data for peanuts, really. Second segment of any national space system would be ground-based infrastructure. Here we have all the bases covered. We have reception, storage, data processing centers. We have the single territorially distributed Earth remote sensing system. It is an interdepartmental system. The principal elements of this are on-ground reception centers. We have a total of 13 of them throughout the whole territory of the country. And last year, even this year, we completed the deployment of 3 reception centers in an Arctic zone of Russia, in the northern Horda, Murmansk, Dudinka, and Anadырь, which for the specialists present here, of course, provides us with a greater opportunity to increase the efficiency of reception of data and for the target use of the whole constellation. We also have deployed a center in Antarctic, which works through the rebroadcasting Luch systems, and just 100 miles from Cuba, from Havana, we have cargo liner with the equipment to install a reception and processing data center in Cuba. So we have quite a broad network of reception centers, which allows us to use all the data that we get from the satellite constellation to receive it, process it, and store it.
All of these reception centers are standardized, and they are capable of receiving data not only from domestic but also international satellites. Another primary segment is storage media. Russia created a federal remote sensing data fund, which is in place and legislated for. So it's in successful operational use. We have the special information ground infrastructure to select data, receive data in near real time. I noted that Russia, like other countries, participates in the Digital Earth project. We opened a domestic component of this project. We were allowed, together with ROSCOSMOS, to open 2 projects. They concern themselves with creation of data infrastructure and remote sensing data infrastructure. These 2 projects work in tandem. The e-Earth, or the Digital Earth, or the Digital Russia from space is the project. So in legislative terms, we have 2 notions: spatial data and remote sensing data from space. And accordingly, there are 2 different data sets: spatial data fund and remote sensing data fund. Together with ROSCOSMOS, we agreed that as of this year, we will proceed to develop our information interaction, to set up single approaches, single data formats, so that we could create digital Earth from the layers covered by the satellites, domestic satellites, and then all the way down to the ground. Development of Databank is not a name in itself. We intend to store it in a single, seamless, mosaic, continually updatable coverage of data obtained by different sensors. We're looking at 15 layers of data, starting from electrical with the resolution of 1 kilometer and revisit time of 30 minutes, and with 0.7 meter resource P, with not as frequent revisit time. But before that, we'll have Canopus with the update rate of every month. Naturally, all of that is already put on the cloud, which we own, RKS Data Processing Center. Apart from data storage and data processing capabilities, we intend to develop there a system of automated services, so that users, when they log into our cloud, would not think twice and receive the information at their fingertips. We are not going to run the raster across the country, but we will provide access rights, and the users will receive vector results, the information per se. I already mentioned the Federal Remote Sensing Data Fund, we intend to cooperate closely with international organizations in setting up virtual constellations or combined constellations. At the moment we have joined Russia-Belarus constellation. They are guided by the same principles. The Belarusian satellite operating on the orbit is effectively another Canopus. So we tend to say that it's not 6 but rather 7 Canopus satellites, which is true to life, actually. We cooperate with Brazil, India, China, South African Republic, and we set up a joint constellation with BRICS countries as well. To enhance our capabilities further, together with Korea and other countries of Europe and the United States of America, NASA, in particular USGS, NOAA, part of the International Charter. This is an effective mechanism, especially when larger territories are concerned, such as Russia or Belarus, Russia or United States. Like there's this big disaster in California with fires reaching residential areas. This is a great example of how different constellations can operate to achieve the shared goal. The International Charter makes it possible to engage up to 50 satellites to resolve one situation. In this situation, the fire monitoring situation, and that could be floods or any other natural disasters. I believe that we need to step up this experience, disseminate it further, because it is certainly beneficial. We will be presiding over the International Charter in the next 6 months, I mean ROSCOSMOS, and we stand to provide fire-related data as it relates to California. I think I would conclude with that. If you have any questions, I mean the other panelists or colleagues from the floor, I'll be happy to answer them. Valeriy, what about IST, that Belarusian satellite? It was designed by Design Bureau Progress, but it is completely independent of ROSCOSMOS activities. Is that correct? If we are talking about IST-2, the one which is in orbit and being used to its purpose, it is indeed a private satellite. In fact, there are two categories distinguishable in Russia: the state-owned and private satellites. The state-owned, or the government satellites, are those that have been designed as part of the Russian space program using the budget funds, and the bulk of the constellation is made up of government satellites. The private ones are international satellites or those designed using private money. It was, in our case, designed by RKC, and it's not part of the state-owned satellite constellation of Russia. But considering its good properties and 3 years of reliable work, And having in mind 3D modeling, we commissioned 2 other satellites from RKC Progress, but those new eyes will have 2 cameras on board. And they will perform the task of stereo imaging.
I'd like to ask you about something about the application of the satellite images. Just like Russia, there are more and more satellite and satellite images in China. So what's the application of the satellite images? Thank you.
Сферы применения самые обширные, и вы прекрасно это знаете.
They are,
Идем в одну ногу.
you know that we keep abreast of the international community. Since we're talking about mapping applications, it could be used for mapping application.
For 3 generators 2D result or 3D result, which one is more important for you?
Сейчас
At the moment it's 2D. In the future we're planning to use 3D in the future, but now it's 2D. But generally speaking, applications are mapping, environmental monitoring, insurance sector, farming, forestry, I mean, a full range, and other colleagues will go over it in depth. Olga, you are the most active listener. Well, I came here for a reason, right? You said that the commercialization rate is not particularly high, commercialization of data. Do you think anything could be done to change the following? In 30 years of our work, 80% of contracts were government-related. Ever since data was declared public, that fragile market collapsed entirely. Don't you think that the policies need to be revisited? The data should be made paid, or if it's free of charge, it should be free charge for everybody. Or maybe we could tap into French experience when they designed satellites and put them in private hands without seeking a goal of paying them, getting a payoff, making sure that they pay off. Thank you, Olga. In fact, we're open to both options. And since the market in Russia is made up of domestic users by 99.9%, so the rules are the same. Besides, according to the data law, any company that carries out remote sensing data-driven government contract enjoys free access to remote sensing data. And we have a couple of examples of that. It's just we want to have a copy of the contract or to verify that you have a contract with the government agency indeed. And then there is an NDA that applies. And we provide data. As for the second part of the question concerning the satellite transfer, go ahead. We are offering it, but no one wants to take it. We said, if you want to be a distributor of data in exclusive whatnot, we will give you a very good discount, but nobody is willing. I think tomorrow during the Industry 4.0 roundtable, we will discuss it. Colleagues, let's continue.